Good morning, class. Today we're going to be learning solving rational equations. However, before we get started, the first 6 problems I've done ahead of time to just review all the different kinds of equations we've solved in the past 12 weeks, just about. So let's just get started, okay? This is the first problem. Anytime you need to pause the video to write down the steps, by all means, pause the video, because I'm going to go through the first part of this fairly quick, but just to recall, this is a rational, and this is a rational equation, but it's because it has fractions in it, but we call it a linear equation because the x here is raised to the first power. And as we recall before with fractional problems, that f word we cannot stand or like, we want to get rid of those fractions, correct? So what we did here, and what I did here, was I multiplied each of the denominators together to find a common denominator. And this is the theme today when we solve rational equations itself with more than just an x at the top. It's when really the x is in the bottom. Those are rational equations, and we'll discuss those later on. So keep that in your mind. We're going to be multiplying by the common denominator today with our solving rational equations. But basically what I did here was I multiplied by 70 to each every fraction. And if you look down below, I multiplied the tops of numerators, and then I canceled each of them out, and I ended up with then solving it like a regular equation from here. And then after that, I got x equals 5/14. Okay, and you need to remember one thing, no matter what, to check this solution right here. Okay, to check that solution right there. Plug it back in. You can use your calculator up at the top into the original equation, and it should work out. If I get any of these problems wrong anytime, you can definitely call me out tomorrow morning when I come in. Okay, but I'm going to move on here. Again, anytime you want to pause this video to check out this first problem, by all means, go ahead and do that. We're going to move on to number 2. This is something we all struggled on. A rational, it's a absolute value equation. And the first goal, as I've told you many of times, is this thing right here. Okay. You need to get this by itself. Luckily for you, I already did that. Okay, it's in the problem itself on the worksheet. It's already by itself. So now we need to break it up into different types of equations. Okay, the first one, right, the same exact way, breaking the walls down, those absolute value bars, or the same thing on the left side, but the right side, we need to make everything the opposite of what was up here, -4 plus 2x. And as you can see, I solved both of them separately. Okay. So I ended up with this one side being 2/3 or this side being 6. But remember what I've told you before when we solve these. And I'll scoot over here real quick. So I solved that one. Again, reminder, you can pause this at any time. Okay, and I'll run through the problems again, but I'm trying to get down to the crux of the matter here with checking solutions. You need to plug each of these solutions in to the top guy right here. And if you see where I crossed out the x equals 6 or 6 equals x, that one will not work. Okay, that one will not work. You'll find. So the only solution would be 2/3. But again, here's my absolute value. First side, and I got 2/3. And then the second side, right side changed the signs. I got x equals 6, which that one doesn't work out. Okay, that's the second type of equation we've learned how to solve. The third type, okay, so the third type, move my pencil up here a little bit, get it up there for you. There you go. And I drew a little u on the side because this is a quadratic equation, the parabola shape. All right, the quadratic meaning the degree or highest power of this equation is to the second power. Now, the first type of solving for quadratic equations is where we can just factor it out. And as I've told you before, set every x equal to 0, and I did that right here. And my two solutions are 0, -1. Again, you plug them back in, and I put a little check mark there because they both will work out. So both these are solutions. You need to check. That's the common theme. You need to check. And you can use your calculator to check those solutions. Okay, that's the common theme for the solving rational equations today. Okay, and you can pause the video if you need to. We're going to keep moving forward. Here's another rational equation problem, and I'm going to scoot my camera a little bit so we can have better access to the next problem. All right, here. Adjust that a little bit so y'all can read this a little better. So this is another rational equation. Okay. However, if you see I labeled the A, B, and C, you cannot factor. So you can go ahead right now and pause the video and try to factor this out, which I know none of you will pause the video and try to factor it out because you'll just take my word for it. So moving on, I'm going to use the quadratic formula. This is another way you might have to solve a quadratic equation. The first one, you could have used the quadratic formula for number 3 here. Could have used the quadratic formula, you would have gotten the same answer. But factoring works a little bit easier, gets you the problem faster. You cannot factor this, so you must, without any doubt, use the quadratic formula. Okay, remember, just plug everything in with parentheses, write it all down. Okay, once I do that, I like to make a list over here, by the way, of my A, B, and C values. And don't forget about that opposite of B, just changing the sign, basically. Make sure when you do this problem, I suggest what you do for this problem. Scoot that up there again, it's falling over a little bit. There we go. Just do the inside of this radical. Just do the inside of the radical, okay? Do the inside of that radical. Let me extend that a little bit for you, okay? And then get the number, which you'd end up with -3. But I just broke it down a little bit further. But when you do all this, just this inside without taking the root, in between there, okay, you'll end up with -3, okay? Now you see there's a negative, and you're taking the square root of that, we can pull out an I, and that would be your answer. Now, I'm not going to expect you to check this one, okay? This one will work out, by the way. I've checked it for you. But again, the common theme is that I'm trying to show you that we've solved many different types of equations many different ways. Again, this is the second way to solve a quadratic, and you have to solve it this way because this one is not factorable, okay? Anytime you want to pause the video, go right ahead and pause it. Okay, I'm going to run through it real quick for you. And you can pause it as I'm running down through here. Let me pick the paper up a little more so you see the answer. So there we go. There we go. Okay, anytime you got to pause the video, go back. Please do so, guys. There's no excuse you can't get all the notes today. Okay. All right. Next 2 problems. Number 5. Okay. Let's look at number 5 real quick here. All right, another quadratic equation. You're like, well, Mr. Hardner, isn't this supposed to be x squared? Well, the whole thing will be to the second power. So it's still a quadratic equation. And if I would FOIL this out by expanding this out, you end up with some long polynomial. But I don't feel like doing that, and you don't feel like foiling it either. I know how much you all hate foiling. So this is the third way to encounter a quadratic. And this time we can use what we've learned in the past with our radical functions, our square roots. So my goal is this time to get this quantity squared by itself. So I added 12 on both sides. Okay. And then I put this below. Then I divided by 3 because this 3 is being multiplied to the whole thing. And I got to this side 4. But then, as I've taught you before, the inverse of squaring something is to take the root. The square root in this case. As I've told you before, the inverse of raising anything to a power is taking its root number, its index number. And in this case, if you should remember, take the square root, there's always a plus or minus option. Okay? And then we solve for x like we do any basic linear equation, but when I add 2 to both sides, I add 2 to +2 and get 4, and I add 2 to -2 and get 0. Again, you need to check each of these, and I've done it for you already. These both work out, but you need to remember that you need to check these solutions because you can have extraneous or extra solutions. So please do that. Again, I want to run through the problem real quick, and you can pause this at any time. I know I'm going through this a little bit faster than normal, but again, pause it at any time. Okay. Number 6. Again, this is a radical problem. This is our last type of equation for today with radicals. Well, it's kind of like number 5 because we're going to do the inverse of that one. So in this case, we have a radical, and our goal is to get the radical by itself. Number 5 was we get the thing squared by itself. This time, we're going to get the radical by itself. And when I do that, I'll get -2 on both sides. Let me fix that real quick so everyone can read that better. Okay. And then the inverse of taking the square root of something is squaring it. And when I do that, that -2 goes away, and I get 4. I add 3 to both sides, get x equals 7. Now, when I plug 7 back in, I put an x next to here. Watch this. 7 minus 3 is 4. The square root of 4 is 2, and 2 plus 2, is that equal to 0? Unfortunately, it's not. So in this case, ladies and gentlemen, this solution, even though we solved and got one solution, this solution does not work out. And I can explain that to you all tomorrow, but this solution does not work out. That's why this is important, because this is an SOL kind of question. Actually, this comes from the SOL, this kind of problem. And everyone will click 7th day of the day. And that's because the SOL test makers are betting on you all not to check the solution. So it's imperative that we check the solution. Okay, so please do that. Again, I'm going to run through the problem real quick. Start up here. Anytime you need to pause this at all, and that's an X, by the way. Excuse me. All right, scrolling down here. Okay, pause it at any time. This X is just like not a solution. Let me fix that real quick. Put it over to the side of the board so it's not like it's associated. I'm just telling you that that's not a solution. Okay, that's not a solution. All right, so let's move on to the main gist of the lesson today, which is our final way to solve equations, which is solving rational equations. So today caps off the last time we got to actually solve something, okay? Solving rational equations. I'm going to pick this up real quick, move this over a little bit. All right, guys, so here's our box on the back here, okay? So just to explain how to solve rational equations, and this will make more sense once I do the problems with you, but fill this in real quick, okay? Just talk about it a while. Before you begin, you look at the denominators and make a list of any discontinuities. That comes from last week's lessons 46 and 47 that these expressions may have. And then we multiply all the terms by the common denominator, or the CD. Doing this assures that you eliminate all fractions from the equation, and you will always, as I've mentioned many times, check your solution. So go ahead and pause this at this part, and when you get a chance and done, you can maybe move on to this video. But I'm going to move on to the back. So I'm going to hold on here real quick so you can click pause, and we'll move on. All right, so hopefully you've paused it. Let me move on to the actual problems. All right, so we're going to do this together. Again, step by step. Anytime you need to pause this to write anything down, please do so. Okay, so here's an example. Come on, camera. Here's an example of a problem that's a rational equation, okay? A rational equation problem. And let me fix the left side real quick. I just noticed there that I wrote it wrong. Excuse me real quick. All right, that's better. So, now that looks better. That's just a 5 there. All right, guys. So it's the problem number 7. My mistake there. Okay, so we see a rational equation. Rational meaning fraction with an x in the denominator. So the first thing I said from the notes from that stuff you filled out was identify the discontinuities. And that comes from last week. Remember the DIS I made you all write down? The discontinuity piece I made you write down? It's what makes the denominator 0. So the discontinuity, the DIS, is going to be, in this case, x equals -2, because I set this equal to 0. This value is what makes this equal to 0. Okay, and just a little tidbit from what we taught last week, we can identify what this discontinuity actually is. We could say this is either a vertical asymptote or a hole. And a lot of you probably checking it right now, maybe, and saying, okay, well, if I try to cancel these won't cancel. This discontinuity would be a vertical asymptote. This is not imperative for a rational solving rational equations today. However, it's just a good review of what we talked about last week. So, but we still need to list these. This is what makes the denominator equal to 0. And if you recall, I plug -2 in and divide 5 into 0, you would get an error. That's an undefined. This will be a vertical asymptote. Okay. But moving forward, we identify our discontinuities. It's the first step. Next, we're going to identify the CD, or in this case, the common denominator. So let me scoot that over a little bit. I'm going to actually scoot it over here. Excuse me 1 second. I want to scoot it around here. There we go. All right. So, perfect. All right. So, I'm going to identify the common denominator, or the CD. And if I scroll back here for a minute, I see one denominator has an x plus 2 in it, and the other denominator is 4. Well, you know how from number 1, and I'll pull that up real quick, from number 1 on the notes today that you might have paused, and you can even go back too, but I'll show you real quick. Remember how I multiplied everything by 70, because I multiplied everything together and got 70. 7 times 5 is 35, and 35 times 2 is 70. Let's see how I did that. Well, I'm going to apply the same kind of principle to this problem here. So this is not as bad as it seems. Okay? I'm going to multiply these two together and put that. That's our common denominator. Let's say that was a plus instead of a minus. You'd say, Mr. Harder, no problem there. I know what the common denominator is. It's the same kind of deal, except we have an equal sign here. Okay? Hopefully that makes sense to you all. But if not, refer back to number 1. I'm multiplying the denominators together to get a common denominator. Now, what I'm going to do is take that common denominator and multiply it to the top of each side of this equation. So I'm going to multiply 4 times x plus 2 over here, up here. Okay, I'm going to multiply the same thing on the other side to 4 times x plus 2 over here. Now, our goal is, at the end of the day, with these rational equations, is to get rid of the fraction. We all hate fractions. I can't stand fractions. You can't stand fractions. This is the way to get rid of them, okay, to eliminate these fractions. So before you start going, okay, I see a cancellation right here, and slow down for a minute. Let's see it actually happen. So what I'm going to do is multiply 5 times 4. But I'm not going to multiply the x plus 20. I'm going to leave that as 20 times x plus 2. Okay. And I'm going to divide that all by x plus 2. This is going to be an easier way to see the cancellation. Some of you might already see it, but I'm not going to skip ahead many steps. I want to make sure we're all on the same page. Same deal here. 3 times 4, but don't multiply this and leave this go. Just multiply the 3 and the 4. And I get 12 times x plus 2 over 4. Okay. And go ahead and pause that. I'll run up here real quick. Scroll it back a little bit. Okay. So, discontinuities, common denominator, and then you can pause this at any time to write this down. Make that a 2 a little better there. Make that 2 a little better there. All right. Anytime. Pause the video, write this steps down. Continuing on. Okay. Well, now we can evidently see the cancellation. These x plus 2's, because it multiplies. If this is an add, if I added here, I couldn't cancel these. But you're lucky. They're being multiplied. So I'm allowed to go, okay, go on. So on this side, what's left is 20. Equals, okay? Okay, all right, you're like, okay, nothing cancels here, Mr. Hardy. Well, wait a minute, the 12 and 4 do. 12 divided by 4, up top will be 3 times x plus 2. Again, pause the video at any time. Now, you could solve this many different ways. You could divide 3 on both sides and get a fraction, but I don't feel like dealing with fractions this moment. I'm actually going to distribute this through. To be honest, I don't feel like dealing with any more fractions. So follow this way. If you want to divide 3 on both sides, you end up with 20 divided by 3. That's a whole fraction, a whole bit of mess you don't want to deal with. So let's just distribute this. Make it easier on ourselves. You might take an extra step to write down, but it's going to be easier to deal with. Okay. Now it's the basic solving equation. You know, we've done this. Kind of like number 1 from our notes today. Then divide by 3. All right. And I'll end up with, to the right here, I'll write it over here, x equaling 14 over 3. And the final step that I wrote in the box earlier was to check this solution. Like, oh, Mr. Hardinger, I got to check this. Yes, you got to plug it back in the whole way up here into this original equation. Your goal is for that 14/3 to plug in here, and you're hoping to get 3/4. Now, if you have questions on how to plug that in, I will show you that tomorrow when I come in on Tuesday. But I'm going to tell you right now, it does work out, but don't look for that gift going forward. You need to personally check these. Today, I'm going to check them for you, and I will show you tomorrow how to plug these properly in your calculator, so that way